So before elaborating bigger polynomials, what I want to do is I want to go over basic ones like we did x square and x cube before. But there are similarities of even powers of x, and there are also similarities of odd powers of x. And those similarities, I have made this chart, and those similarities are written. For example, the red ones are the even powers of x. Even powers means x square, x to the 4, x to the 6, and so on. All of these combined, they all, first of all, they all look like a parabola. I have drawn it here, right here. So they all look like a parabola. They all have the U-shaped graph. I'll tell you what's the difference. The domain is negative infinity to infinity because the parabolas, they extend indefinitely on the left and indefinitely on the right. So domain is always, yes, Joshua. Joshua, you have a question? Because you raised a hand. Okay, that's fine. So the domain for all of these is negative infinity to infinity. And the range, as you know, the parabolas, they strictly stay above x-axis. So the range for these are 0 to infinity, as you can see in my chart. The intercept is 0, 0. If you remember your basic x square graph, it looked like this. So intercept means where it touches or crosses x-axis or y-axis. For these, it's just this point 0 origin, which is 0, 0. So domain is negative infinity to infinity range. For all of these even powers, it is the same. They are increasing on this side, on the right side, which is 0 to infinity, and decreasing from negative infinity to 0. By the way, I use brackets. I believe my lab is using these parentheses here. So you can check what you want to use. Some of the textbook uses brackets, some of the textbook uses parentheses. But as coming back to increasing, decreasing, they are increasing in this part and they are decreasing in negative infinity to 0. The end behavior, which is a new term, end behavior of these. End behavior means towards the end, where is the graph going? So towards the end, this parabola is going here and here. So there are two ends. One of the ends is negative infinity, the other end is positive infinity. So on the left side, the parabola is going in this direction right here. And on the right side, the parabola is going in that direction. So that's called the end behavior of your even functions. Coming to the odd functions or odd powers, these are the powers, and I'm going to include x as well because one is odd as well. So x cube, x to the 5, and so on. The domain for all of these, let me draw just x cube here. So x cube looks like this, as we have seen before. The domain for all of these is negative infinity to infinity. It extends indefinitely left and right. It extends up and down indefinitely. So range is also negative infinity to infinity. Intercept means it crosses x or y axis. Again, it has only one intercept, and that's 0, 0. This function is always increasing, right? So this is, as you can see, if I start moving in this direction, it always is going up. So it's always increasing from negative infinity to infinity. And the end behavior of this function, as you can see, the end behavior, where is it going? This direction and this direction. So all the odd powers, the end behavior is this. It goes up from the right side and it goes down on the left side towards the negative infinity. Now, all the odd powers imitate x cube shape except for x. Okay, x is a straight line, y equals x is a straight line linear function with slope 1. But all other odd powers, they behave the same. The shape is very much the same. So what is the difference? Let's look at the difference between the two graphs that I have drawn here. In the first one, I have drawn x square and x to the 4th power. The red function is your x square and the blue function is your x to the 4th. If you look closely, what's the difference? This point is your, right here is your -1 and right here is your 1. Between -1 and 1, x to the 4 is lower than x square. between -1 and 1, the blue graph is lower than the red graph. But after 1 or even before -1, the blue graph is higher, right? So blue graph, because of x to the 4, it is approaching infinity. It's going up faster. The power is higher. Number 4, as you can see, x to the 4th, if you do 2 to the 4th, versus you do 2 to the square, so x versus you do 2 to the square, clearly 2 to the 4th is way higher than 2 square. So x to the 4 approaches infinity faster. But in between -1 and 1, in between this small interval, it's actually lower. If you look at 1/2 to the 4th, I'm taking a point in between -1 and 1. And I take a point in between -1 and 1, and that's my 1/2. Now, if I fourth power 1/2, square power 1/2, this side is more. Half square is more. Half square is 1/4, and half to the 4th is 1/16. So what this is telling me, let me show you again. The blue graph is x to the 4th. So this is my blue. Okay, so this part is my blue. And this is my blue. This point, I input 2 into x to the 4th, right? So if I input 2 into this x to the 4th, I get 16. Similarly, if I input 2 into my x square, so if I have x square function and if I input 2 here, I get 2 square. Which value is more? At the point 2, which is my right here, which has a higher value? Of course, this will have a higher, the blue graph, if I extend it further, the blue graph will have a higher value. So the blue graph is it's approaching to infinity in a faster manner. But if I look in between -1 and 1, the blue is actually compressed. The blue is lower than the red one. The reason being, if I pick any number between -1 and 1 and square it or fourth power of it, the blue value is smaller than the red value because 1/16, if I fourth power half and square half, the blue value is smaller than the red value. Do you get it? No. Are you understanding it? Similarly, let's say if I do x to the 16th, x to the 6th, x to the 6th will even be lower. Okay, here will be lower. But once it approaches 1, it's going to be even faster than your x to the 4th. So this is the green one. If you can see the difference, the green one is x to the 6th. From 0 to 1, it will be lower. Okay, because half to the 6th is even smaller than half to the 4th. But once it crosses the point 1, it's going to go up very fast, faster than your x to the 4th or x to the square. And keep on increasing the powers, it's going to be the same. X to the 8th will even be lower than x to the 6th, but then it's going to be faster than the green one after 1. Okay. Same thing happens with your x to the cube and x to the 5th. X to the 5th, which is the blue one, is lower than x to the cube before 1, and then from -1 to 0 as well. Again, this right here is your x to the 5th. But after 1, it picks up very fast. After 1, it goes to infinity faster. So that's the primary difference between different powers of different cubic powers or different odd powers or different even powers. Otherwise, the shape is the same. The domain and range are the same. The intervals of increasing and decreasing are the same. Okay. So I have written some things here that I was explaining. You can read it again. It is posted on your MyLab. So I'm going to go over to this black part right here. Transformations are when we move it up, shift it up, shift it down, left, right. Again, they behave the same way as with other functions, as with radical, as with absolute value or other functions. For example, x to the 5 plus 2, if I ask you what is happening, it is the shift up, right? Shift up 2 units. Negative x to the 6th is the reflection, if you remember. So if I want to draw these, the first one The x to the 5 plus 2 is my something like this. You don't have to show any difference between x cube here. You just have to draw a basic function, an odd power function, and shift up to. So this is my x to the 5 plus 2. Negative x sixth. Negative x sixth is your reflection about your x-axis. It's a usual parabola. Just reflect it as we have done before. This is negative x to the sixth. Now the domain is the same, but range changes in this one. The range is your, and also intervals of increasing and decreasing. The range for this particular graph right here is negative infinity to 0. And if you look at the intervals of increasing, decreasing, it's increasing here and decreasing here. So certain things change when you do transformations, but transformations are behaving the same way as we have done before. The vertical shifts, the horizontal reflections. For example, the third one is your left shift, right? Shift to the left by 7 units. And the fourth one is the stretch. Any question up till here? So I have taken different powers of x's here, and I'm doing the same kind of transformations. Okay, so next comes graphing polynomials with these higher power of x. Look at this problem right here. Right here, look at this problem. Let me read it. Suppose I have this function right here, and I have given, this is something you have been learning in the last week. X equals 3 is a 0, factor f completely and graph it. Okay, so the new thing is here, which is the new thing is just graph it, right? You have been factoring these kind of polynomials using synthetic division, and I'm going to continue with that. So using synthetic division, anybody needs review on synthetic division, or just I can just do it quickly?
Question.
Jackie, yes.
It's Rebecca, but
Oh, sorry.
sometimes it says like a -3 and you'll have to divide it by the opposite, which is 3. In this case, it says x equals 3 and you're dividing by 3. So when do you know when to do the opposite? Because I was always getting confused. I do it both ways to see which one give me a 0 at the end.
Okay, okay, good question. Good question. Okay, let me clarify. So let's go back. Suppose you have, suppose this is a 0, right? If x equals 3 is a 0, so let me write down something here, a 0 and a factor. So if 3 is a 0, x minus 3 is a factor. Okay, now on the problem, any of these could be given. Both are the same thing. If x equals 3 is a 0, basically you divide by a 0 here. Okay, you enter the number that's the 0 on this place right here. I'm talking about this place as a dividend, sorry, as a divisor. The number you use for the divisor is a 0. Now in this, 0 was given, x equals 3 is a 0. Now for example, if this was given, instead of this, I do x minus 3 is a factor. So given this polynomial, let f of x be this. Given x minus 3 is a factor, factor f completely. If x minus 3 is a factor, I know x equals 3 is a 0, right? Because you set it equal to 0 to figure out. Once you have this x equals 3, you're going to write x equals 3 here. Okay, now if for some reason x plus 3 is given, then the 0 becomes negative 3. It's the opposite sign. Both are the same things. This guy is called factor of a polynomial. This guy is called 0 of a polynomial. And whatever the 0 is, that goes to this yellow part right here, this yellow highlighted part, this divisor part. Does it make sense, Rebecca?
Yes, thank you so much for clearing that up because I was so confused. But now,
Okay, great.
thank you.
Okay, so since 3 was a 0 here, or x minus 3 is a factor here, I'm going to do long division, synthetic division with 3, copying 1 as it is, then multiply these two, 1 and 3. I get a 3, that's my next entry. Add them, I get a 0. Multiply 0 by 3, I get a 0. Again, adding these two entries, I get a -1. Multiplying -1 by 3, I get a -3 and 0. So this is correct. So my division is correct, and x equals 3 is actually a 0 of this polynomial. I have to factor it completely, right? So I have to see what my quotient is. For my quotient, the first term is x squared, the second term is 0, which is x, so I don't have any x term, and the last one, the constant, is -1. So the quotient is just x squared minus 1, which can be factored as x minus 1, x plus 1. Now, I don't know if you remember this, the difference of two squares, I have used this here to factor x squared minus 1. You can use other things to factor, but this is very useful if you have like difference of this can be written as x squared minus 1 squared. You have x minus 1, x plus 1. Similarly, if you have x squared minus 4, this can be written as x. This is totally different. This can be written as x squared minus 2 squared because 4 is a 2 squared, and this is x minus 2, x plus 2. This formula is called difference of two squares. Now, there could be other techniques to factor. If you want, I can tell them. But this is the easiest way to see that x squared minus 1 is x minus 1, x plus 1. So I have three factors now. Let me erase this first. I don't have this one. So one of the 0 was already given, which is 3. The corresponding factor is x minus 3. The other two factors that I have found are x minus 1 from here. These are the ones I found, and x plus 1. So these are the ones we found here, and this was already given. Okay, now corresponding to x minus 1, what is my 0? My 0 is plus 1. Corresponding to x plus 1, you set it equal to 0. What do you get? Your 0 is -1. Okay, so 3 was given, plus and minus 1. Using synthetic division, we found that those two are also zeros of the polynomial. Now, zeros means what? Zeros are also, look at this highlighted, zeros are also your x-intercepts. When I say a function equal to 0, so those are basically your x-intercepts as well. Is this okay, or shall I explain more that zeros are also x-intercepts? So when I talk about zeros of a function, those are x-intercepts also. Um, it's okay. So what I'm saying is the function in the factored form is written like this: x minus 3, x minus 1, x plus 1. And if I set this equal to 0 from the first one, and that's how you find your x-intercepts, you set your y equals 0 or the function equals 0. From the first one, from the factored form, I get x equals 3, x equals 1, and x equals -1, which are right here. Okay, so zeros are your x-intercepts. Thus, x-intercepts are given by 3, 0, 1, 0, and -1, 0. Those are your three x-intercepts. Your y, I'm trying to graph it. So I'm trying to grab as much information as I can to graph the function. I got my three x-intercepts. My y-intercept is if I go back to function, let's go back to my basic function right here. My y-intercept, I'm here. My y-intercept is when I set x equals 0. So if I set x equals 0, this is gone, this is gone, this is gone. I'm left with only 3. Y-intercepts are easier to find. So my y-intercept is 3. The function is going to cross my y-axis at the point 3. So my y-intercept is right here, which is 0, 3. And these 3 are my x-intercepts because y value is 0. Leader of the polynomial. What's the leader of the polynomial? Who's leading this polynomial? Highest power of x, which is x cube here. So leader is x cube. It means the end behavior of the function would be like the odd powers, and all odd powers have this as the end behavior. They behave like this usually. Now, all the x cube and x to the fifth behave like this. But once I start adding terms, things may happen in between. Okay, but towards the end, it's going to behave like x cube. So leader of the polynomial is x cube. So the end behavior, or towards the end, the function is going to behave like x cube. So something like this. Domain is negative infinity to infinity. So let's graph. Look at the graph. Uh, this is my end behavior. I think I have explained it very well here. So this guy right here, um, that's my end behavior. It's going down indefinitely. It's going up indefinitely here. In between, it has to cross x-intercepts. I found these three as my x-intercepts. If you remember, x equals -1. Those were my zeros. X equals 1 and x equals 3. Remember, we found these using synthetic division, and this was given. So a function has to cross all of these. These are my x-intercepts, and also has to cross at this 3, which was my y-intercept. Now you have to draw a rough graph. Okay, so don't worry about where it's turning. We don't know where it's turning, but we know that it is going to turn because it has to cross through 3. So if I have to draw the graph in a very rough manner, this is using Desmos. What I'll do is I'll start marking my zeros from the left side. The leftmost is -1. So I'm going to mark -1. Then I have 1, and then I have 3. The end behavior of my function is it has to go like this at the end, right? So first, and it has to cross somewhere here 3 as well. So somewhere here, I'm going to pass through through -1 first. And then it has to turn, it has to cross 3 and turn. You can turn anywhere, but then it has to cross through 1. And then it has to turn somewhere in between and then cross 3. And at the end, it has to go this way. Okay. So when we ask about rough graphing, this is a rough graph of this function. Now, from this particular graph, you can actually tell me the zeros. Now, the question could be reversed, and I think I will be giving you the reverse version. The reverse version meaning factor this, given this black graph, tell me the zeros. The zeros are -1, 1, 3. So a factored form of the polynomial. So a factored form of the polynomial would be x plus 1 from here, x minus 1 from here, and x minus 3 from here. That's it. So this will be your factored form of the polynomial of this graph. Okay, if graph is given, you have to write this. If polynomial is given, you have to do synthetic division and then graph the function. Okay, let's look at another example. Yes, Naomi.
How did you know that it went down to -3 on the graph?
-3.
Yeah, because it's hitting the x-intercepts, but then it goes down to -3.
Oh, I don't know that. I don't
Oh,
know that. That's just a rough estimate. I don't know that. We don't know where it's turning, but we do know it's turning somewhere, and that's why I'm saying it's a rough graph.
okay.
Okay, so we don't know where this is what you learn in calculus, where it turns exactly. So in here, you only know that it's going to turn somewhere between -1 and 1, turn somewhere between 1 and 3 as well. Okay. So don't worry about the exact turns where it's turning, but somewhere it has to cross -1, it has to cross 1, it has to cross 3. So between -1 and 1, it has to make a turn. Between 1 and 3, again, it has to make a turn. Okay. I don't know how it's turning. We don't know yet. I mean, from the graph, from the exact graph on Desmos, I can tell it's turning at -3. But when I'm drawing a rough graph, I may not turn at -3. I may turn at -5 or -1 or wherever, but I will give a turn for sure. Make sense?
Yes, thank you.
Okay. So let's look at this another polynomial. This is f of x equals same thing. F of x equals a cubic polynomial. One of the zeros is given, factor f completely and graph it. I'm not going into synthetic division. No, actually, I want to go because Rebecca, you had a question, something similar. So if I want to write the coefficients of x cube, I will be writing first x cube, then x square, then x, and then the constant. If you see x squared term is missing in this one, so I'm going to put a 0 here for the x squared term right here. So always when you're doing synthetic division, you must have a coefficient, you must have a number for each power of x. If something is missing, for example, in this polynomial, x square is missing, so put a 0, insert a 0 for that x square. Otherwise, you won't get the exact or the correct answer for the quotient. So again, synthetic division is applied or performed in the same manner. 1 is carried first, then multiply the -2, add them, you get a -2 right here. Multiply this -2 by -2, you get a 4 right here. Add these two, you get a 1. Multiply 1 by -2, you get a -2 and 0. So it means you have done it correctly because -2 is a 0 right here. So the zeros go right in the dividend, in the divisor part. And the quotient now is x squared minus 2x plus 1. If I factor x squared minus 2x plus 1, you can factor it. You can use quadratic formula, whatever you want to. But when I factor it, I get x minus 1, x minus 1. So basically, I'm getting x minus 1 whole squared, right? Or when I try to figure out the 0 from here, the 0 is x equals 1, but repeated twice, right? Now the question is, how does this affect the graph of the function if a 0 is repeated twice? So again, I have calculated, I'll come to the graphing portion. The y-intercept is right here, 0, 2, because if you go back to your function, if I set x equals 0 here, I am only left with 2. So my y-intercept is nothing but 0, 2. So I have my y-intercept. I have my x-intercepts as -2 and 1. -2 was given. 1 is repeated twice, right? So let's look at the graph. You will be you'll be amazed to see how the graph behaves at those intercepts which are repeated twice. This is something interesting. So again, it's a cubic polynomial. So at the end, it's going to behave like this. This is my x-intercept, which was given. And this is my x-intercept, which I found is repeated twice. So what's going to happen is, let me draw first. And then, so if I have to draw the graph, my two x-intercepts are x equals -2 and 1, but 1 is coming out to be repeated twice, right? Because the zeros are coming out, the factors are coming out to be x minus 1 whole squared, as you see here, x minus 1 whole squared right here. So it means 1 is occurring twice. Now to graph it, I will be first graphing -2. For example, this is my -2 and this is my 1. Those are my two x-intercepts. This is my cubic polynomial. So end behavior is definitely like this, right? So, and my y-intercept is somewhere here is my 2. It's going to cross here. So I'm going to cross at -2 in the same manner because it is a 0. And somewhere between -2 and 1, it has to cross because 1 is also an x-intercept. So I don't know where it's going to cross. So I'm going to do this. And then since 1 is repeated twice, I'm not going to cross it. There is no other x-intercept. If I cross it, I cannot turn it again. So since 1 is repeated twice, it's going to turn like this at 1. Turn like this means it's going to behave like a parabola at 1. Why? Because the function has this has this component in the factored form. If I write the factored form of my function, given function, look here. So given this function, whatever your function was, the factored form is x plus 2, which is coming from here, this component, and from 1, it's x minus 1 whole squared. This is the factored form of the given function, which was right here, which is the highlighted yellow function. X, because if I draw my chart again of zeros and factors, -2 was a 0. So x plus 2 is a factor. 1 is a 0 repeated twice. So I can write 1 and 1. And the corresponding factors are x minus 1, x minus 1. If I multiply all these together, that's the factored form of your function. But when I multiply together, I can rewrite these two as x minus 1 whole squared. So basically your function is x minus 1 whole squared and x plus 2. So since this factor has has a quadratic form, or it is x minus 1 whole squared, the graph of the function has to behave a quadratic here. It's not going to cross it. It's going to behave at that particular point. It's going to behave like a tiny parabola. Okay. But at the point at the point -2, it's going to behave linear because this is a linear factor. So if I write here, this guy is called a linear factor. So the function is going to cross this one like a line. This guy is called a quadratic factor because of the power 2. And the graph is it's gonna behave like this or this. Either way, it's either going down or up. But at that particular point, it's gonna look like a tiny parabola. Okay. Any questions? No? Okay, let me go down because I have a couple of more examples. Let's look at this one. This is a 4th degree polynomial. Ask questions if you have any. This is a 4th degree polynomial. 2 of the zeros are given. I'm going to go quick right here. So this is a 4th degree polynomial and 2 zeros are given right here. X equals 2 and x equals -3. Find the other zeros and graph f or factor f, whatever. There could be other parts. To graph f, we need the domain, which will be -infinity to infinity. X-intercepts, which will be your zeros, y-intercept, which will be -36 in this case, and the end behavior. Your end behavior, because of the x4th term, it's going to be something like this. All the even powers, the end behavior is going upwards in both directions. X-intercepts are your zeros, right? 2 of the zeros are already given, 2 and -3 are already given. Right? We need to find 2 more. It will have 4 zeros. Now to find the other zeros, I have to go and use my synthetic division, which I have done right here. I have first divided by 2. Same way, I'm not doing the synthetic division. This is my x to the 4th, x to the cube, x square, x, and the constant. Now once you have divided, use the quotient and divide it by -3. This is something different between the cubic polynomial and the 4th polynomial, 4th degree. For the 4th degree polynomial, you will be dividing twice. First, with the first zero, you could have used -3 first, doesn't matter which one you use first. But then since -3 is left, divide the remaining quotient with -3. You will end up with 3 terms. That's your new quotient, and that's x squared plus 5x plus 6. You should always have the squared term at the end. You should all, if I look at the black one is cubic. So from step 1 to step 2, I have gone to the cubic. From step 2 to step 3, I have the quotient is x squared. Okay. So starting with x to the 4th, first step, the quotient is x cubed. I need one more step since one more zero is given. So I move down to quotient x squared because I know how to factor x squared. I can use quadratic or I can use my middle term split. So it's x plus 3, x plus 2. I have found 2 more zeros, which are -3 and -2. But -3 was already given. So it means -3 is occurring twice. These 2 were given, the black ones. And so if you look here, I'm on this part. The black ones were already given. And I found these ones. So as you can see, the -3 is occurring twice. The factored form, the complete factored form, if I combine these two right here, I can write this as squared. So the zeros are 2, 0 from here. -3, 0, multiplicity 2 or repeated twice. And then -2, 0 from here. Right? So again, I have written some information. If we graph f, it's going to cross x-axis linearly at -2 and 2. And it's going to behave quadratic because of the repeated factor. It's going to behave quadratic at -3. End behavior is like this. So as you can see, I'm going to graph it here. I have graphed it here. Those are my intercepts, -3, -3 right here, -2, and 2. It's going to behave U-shape at -3 for sure because it is a repeated intercept. Then it's going to behave linearly here, and it's going to behave linearly here. So if I draw my graph, it's going to turn right here like a U, and then linear, and then turn somewhere here, and then linear going up again. Okay, and the exact graph is right here. Right here. So they have the y-intercept also, which is -36. And I can see a very small u here. It's not very clear, but this is my u part right here for -3, and then linearly here. Okay. Any question? Okay, let me do these as well. Are you still with me?
Yes.
Okay. Okay, let's look at these one. These are the questions from the homework. The first one is match the graph. Factored form is given. So if I look at this, couple of things to note. This will give me x equals 0 as a 0. This gives me x equals 4. These are the easy ones. X square minus 9. Again, difference of two squares. This is same as x squared minus 3 squared, which is same as x minus 3, x plus 3. So if I want to write this in the linear form, I can rewrite this polynomial as 2 times x times x times x, that's my x cube, times x minus 3, x plus 3 times x minus 4. This is my polynomial, first of all, written in the linear form. Okay. Now, how many x's are there? If I start multiplying x's, there is 1. Let's look at, there is 1, 2, 3, 4, 5, and 6. So if I multiply all the x's together, definitely my answer will have x to the 6th power and some other factors. But my leader will be x to the 6th. If my leader is x to the 6th, it means my function is going to behave like this and this at the end. And actually your job is easier because there is only one graph which behaves like that. The others are going down. There is only one graph which behaves like this. And if I look closely, since this is one of the factors, let's ignore these for a second. I'm on x minus 3. Graph is going to behave linearly here. Graph is going to behave linearly here. Graph is going to behave linearly here as well. So at -3, 3, and 4, the graph is going to behave linearly. This point is your -3. Graph is going linearly means like a line. At 3, it's behaving like a line. If I look at closely, it's behaving like a line. And also at 4, it's behaving like a line. Those are my intercepts. Those are my zeros. So x equals 3, x equals -3, and x equals 4. The other zeros are here, these three right here, x, x, x. This gives me x equals 0, x equals 0, and x equals 0. But x equals 0 is repeated not one time, not two times, but three times. So if x equals 0 is repeated three times, the graph is going to behave like a cubic function at 0. So it's going to cross 0 like this. How does your cubic function behaves at 0? Like this. So if you have a factor, let's say, let's assume any number. If let's say it's a, if you have x minus a, and this is your a right here, that's my x-axis, and that's my a, the function is going to cross a like this. If it is x minus a square, the function is going to cross at a, and that's my a. It's going to be something like this. Either ups, it could be either way, either here or here, depending on the plus minus. Now, if it is x minus a cube, the function is going to cross at a like cubic function like this. If that's a 0, okay? If a is occurring thrice, a is occurring twice, or a is occurring once. For example, in this problem, 4 is occurring once. Look here, 4 is occurring once, -3 is occurring once, 3 is occurring once, but x, 0 is occurring thrice. So that's why at this point, the function is crossing your x-axis like a cubic function. So this was an easy polynomial. Let's look at, so I have tried to explain it here. You can, what I'm trying to explain here, you can read this. The zeros are 0, 3, -3, 4. I can say multiplicity 1 or behaving linearly. So at this point right here, the function is behaving in a cubic fashion. Everywhere else, it's linear. Everywhere else, it's linear. Something like this, and like this. Okay, that's one of the problems from the homework. Let's look at the other one. The function is written here. Use the graph to factor the polynomial. So again, I want to write the factored form from the graph. Let's look at some of the zeros. Let's look at -3. The -3, the function is behaving like a parabola, right? So -3 is occurring twice, for sure. Corresponding to -3, these are my zeros and these are my factors. So corresponding to these two are my factors. 0, the function is crossing 0, but linearly. So I'm going to write 0 is a 0 and factor is just x. Again, 4, the function is crossing linearly and the factor is x minus 4. These are the complete answers. The function is not crossing anywhere else. Multiply all of these. That will give you the factored form of this question. So again, I have written twice here. If I go back, if I multiply this, it will be x plus 3, x, and x minus 4. And that's what I have written here, x plus 3, x plus 3. So uh, it means x plus 3 is occurring twice. So x plus 3 whole squared, one of the x's, and x minus 4th. So I can rewrite x in the front. It doesn't matter. It's not required. But I can rewrite x. Usually we write x first and then x plus 3 whole squared and x minus 4. Can you tell me what is the leader or the degree of this polynomial? This guy right here. Can anyone tell me what's the degree or the leader of this if I multiply all the x's, what will be the leader of the equation? Anyone? You can write. There is one x here. There is x plus 3 and x plus 3 here. And then you have x minus 4, right? If you multiply all the x's together, if I multiply the first two, I'll get x squared. And then if I multiply continue, I'll get x cubed. Continue, you get x to the 4th. So I will definitely have x 4th as my leader in this equation. So my graph must behave like x 4th at the end, which is correct, right? Because your graph is going like this. So you must check your answer. For example, if I check, I'm getting an x to the 4th, and I can see my graph is behaving like x to the 4th at the end. So these are the two questions, the two hard ones from the exam, not from the exam, from the homework. 17th. I have one more question before I end, which is not here, which is right here. And I would want your answers on this one. Tell me, write the factored form of this one. Write the factored form of this particular function. Give me the zeros first of all, everyone. Start giving me the zeros of this polynomial. You can unmute yourself and talk now. Give me the zeros. Are you with me or no?
1.
1 is a 0. I'm going to stop the recording and then